These are the two examples that we were doing in class of how to solve with rational exponents. The first example had this problem here, and remember the first rule is to isolate the expression with the rational exponent. And so you can see that we have this rational exponent here. So this group x minus 2 needs to be isolated, meaning we need to get rid of the 3. You cannot distribute that 3 because this has got a power to it. You can't just distribute it in here. So we're going to divide both sides by 3. And we get that it now equals 8. The next thing you want to do is where the variable is, you're looking for this, we're saying, oh, I need to get rid of this rational exponent because it's got the variable trapped in there. And to do that is to raise this to the reciprocal power, because we're just going to multiply power times power, and that's going to equal 1. And so by doing that, we now have x minus 2 to the first, which is just x minus 2. Now the fact that we have a rational exponent over here on the right, that's okay because this is a number, and we're going to simplify that. And we notice that what that means, because this denominator is 3, is that it's a radical with an index of 3, meaning it's the third root of 8. And then the numerator of 4 means afterwards I'm going to raise that to the power of 4. So the cube root of 8 is 2, and so 2 to the 4th power is 16. And so we have x minus 2 equals 16, which means x equals 18. Now we're not done with this problem because you always have to check your solutions. So we take the 18 and we plug it back into the very beginning of the problem here. We plug in 18 minus 2, we take the 3/4 power times 3, and we do in fact get 24, and so we checked our solution and it is 18. The second example had two terms with rational exponents. Well, we still need to isolate so that we have one term on one side. So we're just going to add the 28 minus 2x raised to the 1/4 power to both sides. And we end up with this expression that has rational exponents on both sides. The next step is to raise both sides to the reciprocal of the exponent. But which reciprocal? We've got this rational exponent of 1/2 and we have this rational exponent of 1/4. So are we going to raise it to the 2/1 power, or are we going to raise it to the 4/1 power? Well, I'm going to kind of show you that in a way it's not going to matter. So let's just try raising it to the 2/1, meaning we're going to square both sides to begin with. When you multiply on this side the 1/2 power times the 2/1 power, well, those are reciprocals of each other. So that's just the first. And so we end up getting x minus 2 to the first. But over here on this side, you've got the 4/1 times, 1/4 times 2/1, which leaves you still with 1/2. So we still have a term with a rational exponent. And so we need to get rid of that rational exponent, and so we're going to raise both sides to the 2/1 power, meaning we're squaring both sides again. And if you think of it, here in red we squared both sides, and now in green we're squaring both sides again. That's the same thing if we had just raised both sides to the 4th power. And when we do that, we end up clearing, and we no longer have the fraction 1/2 or anything. We just have this on the left-hand side, x minus 2 quantity squared equals 28 minus 2x. Well, we can square a binomial, and x minus 2 quantity squared is the first one squared and the last one squared, and twice their product. So we've got the x minus 2 quantity squared, and that still equals 28 minus 2x. So we're going to solve this. Since it's a quadratic, we're going to get it to equal 0. Then we're going to factor it. And we see that we have two possible solutions, x equals 6 or x equals -4. But remember, you must check your solutions. When we plug in the 6, we get 6 minus 2 is 4, and the square root of that would be 2. And then you're going to find out that this also equals 2. And so it does work. 6 works. But when we plug in the -4, this is a bigger problem. Plugging in the -4 up here, if I have -4 minus 2, I'm going to have -6, and I want the square root of -6. Well, we're going to get a complex number. That's not going to work out. So 4 does not work. The only solution is x equals 6. Make sure you're checking your solutions. So these are the worked out of the 2 examples from class.